Hello. Today I want to talk a little bit about the GraalVM, which is an Oracle project, and it provides a virtual machine that allows you to run multiple supported languages, as well as compiling Java applications to native code. So here I'm looking at the homepage of the GraalVM project, and my main interest is the compilation of Java code to native images that can run potentially faster, and I would like to avoid running full-blown GRE if possible. In my case, professionally, I have to write some command lines applications once in a while. In the past, I've done so using some other programming languages such as Python. Occasionally, my client doesn't allow me to run a Linux desktop, so this is a little bit annoying, because I'm not very good at C++ and other native languages. So what I would like to get from the GraalVM project is the ability to write occasionally some Java-based command line applications. If possible, the code has to run faster, and I don't want that Java application to eat all my memory. And what I'm also aiming for is reduced image size for Docker. In terms of experimentations, I downloaded GraalVM and I tried to build at first a simple command line application with no external dependencies. And in this case, what I'm trying to do is to update my host file based on some external program, just to set the IP address of that would be pointing to some name. And my other experiment is with Spring Boot. And what I did in that case, I created a Docker image, and it's running Spring Boot 2.1. Doesn't have much functionality. It's pretty much a hello world with close to zero dependencies. And there are some limitations to account for when trying to do the same, especially for GraalVM features that are either buggy or basically incomplete in terms of the range of applications and the Java features that can be easily compiled to native code. So let's take a look at that command line application. And again, what I'm just doing is running some external shell command and updating my host file. That host file looks like this. So what I want to do is to have an entry called apphost pointing to some kind of IP address. And let's jump to it. Okay, so this is a simple Maven project. Have no dependencies. I'm using Java 8. And I have a single class in this project. So what the code will do is get the IP address associated to my wireless network interface and capture that IP and point it to an entry called app host. So when we look at how I wrote the code, there is not much into it. I'm using java.io and io and a few classes from java.util. One thing that I notice is that when you want to consume the input stream of a process, there is no reliable way to wait for the process to exit just using, for example, p.waitFor without any kind of arguments. So what I'm doing here, I'm trying to read the output of a process, and instead of only relying on whether or not there is still some input to consume, I'm looking at whether or not the process has exited. And I'm checking for it every 10 milliseconds. So without it, what you get when running a native image is an exception, because you assume that the process has exited, but it hasn't. So I had to change a little bit the way that I would normally write that kind of code. The rest is pretty standard. So here is the main method that is calling the shell script prior consuming the input stream in the function that I just showed you a couple of moments ago. So I run the command and I return the string output from it. In this case, I have a test file that I want to update. I just want to add an entry pointing to my Wi-Fi IP address. In the real world, what I would probably do is have a bunch of microservices, run some command lines to get the IP addresses of those things, and just reference them directly in the code. In the case of, for example, Kubernetes and Minikube, if I start Minikube locally, I don't want to have to look at the IP address all the time. So in such a case, I would run the Minikube IP as command line, capture the IP address from the result, and update the host file. On Windows, I would probably have to flush my DNS just in case. So I have that file that I want to update. I check whether or not I'm able to read the file, write to it, and if the file exists. I prepare my command line. I capture the result in a string called replacement. If the output from that command line is empty, I just exit. And in such a case, I would have previously written the stack trace to the standard output. Using Java streams to read the lines of the file. And I'm not using here a random access file. So I read the file and I create a temporary file in order to do some replacement. This is pretty much standard Java code, nothing special. I didn't really have to alter the way that I would normally write that kind of code just to make it work under GraalVM. Here, that weird stuff is just an alternative to using an atomic boolean, because if I want to access a variable outside the scope of that closure here, I would either need to have a Java reference, for example, an atomic boolean that I would set to true or false. The other way of doing it is just to create a byte array with just one entry. And if that value is 0, it means that the flag is set to false. And otherwise, if it's 1, it means that it's set to true. Yeah, in real life, I wouldn't really bother with that. I would just write an atomic boolean. And that's pretty much it. So in terms of build, let's look at how I build it. So this is a Maven project, so I would use the Maven command line. And I have downloaded GraalVM version 1.0.0 RC5. And the latest version is release candidate 6, but it has a bug. So that's why I had to downgrade to RC5. So once I set my Java home to point to my GraalVM installation, and once the Maven artifact is ready, I just called one application called native image. That native image program will do whatever needs to be done in order to translate the Java code to native code. And here I'm passing a bunch of arguments, the application name, so that will also be the name of the resulting binary. And my main class here is called apphost. So let's try to build it. So this is not really fast. I don't know exactly what's going on. Sorry. But it takes a while even for a simple program to translate it into native code. So here we see that I have the binary ready. And if I look at my system clock, it was just built a few seconds ago. And let's try to look at the size in a more interesting format. So the binary is about 6 megabytes. And if I compare it to the jar file, jar file is just around 1 megabyte, but if we add the GRE required in order to run it, yeah, it's a whole lot more. And that's pretty much it. It took very little time to run it, and I'm very happy about it. And if I look at my host file, I see that I have an IP address here with the entry apphost. So let me try to delete it. And let's rerun the application to see if it's going to get updated. And yes, it was created successfully again. So let me go back and I run it again. In this case, it should remain the same, just one entry. And that's pretty much what you would expect. So in this case, for that simple command line application, I didn't have to do some crazy things to get it to behave correctly. So as I mentioned earlier, my only problem was around detecting whether or not a JVM process has, an external process has exited successfully. So I'm just relying on that method, p.waitFor process.waitFor, instead of just looking at whether or not there are no more bytes available to read, or just doing p.waitFor without any arguments. So writing something like that just doesn't work. That's all I wanted to talk about for this application. So let's look at a Spring example. So in this case, it's a Spring application. This is just a hello world. And if I look at what I publish on GitHub, when you run it, it will just display hello Graal on the browser. And sorry, there is not much into it. I'm using Spring Boot 2.1 dot something milestone release. And yeah, I didn't do much in terms of experimentation here. I looked at an existing GitHub project, and that one was built on top of Maven, and this is where I noticed that there was an issue with the release candidate 6. So I also downgraded to release candidate 5. And it's pretty much exactly the same code. So I'm just going to show it from my machine. So instead of using Maven, I'm using Gradle, but yeah, it's not a big difference. If I look at the build file, I'm using 2.1.0.m3 for the Spring version. There are a couple of dependencies that are required, such as JZlib. And I'm using Webflux, Netty. I had to exclude some native code from Netty, just to make sure that it doesn't interfere with GraalVM execution. Aspect J, so same as the original GitHub project where I looked at some sample code. And yeah, I'm just making sure here that I'm not including all those Netty native libraries. That's pretty much it. The main class is very basic. So here I'm preventing things from happening per bug on the GraalVM issue tracker. I'm specifying that the application is reactive, not using any special Spring annotations, no class path scanning or anything like that. Here you can see all those route functions that you would specify in a Spring Boot 2.x application. And that's pretty much it. I just follow the instructions and that existing project on GitHub, and that was kind of good enough to run it locally. So if I look at how it's built, so the first step would be to call Gradle assemble in order to package Uber jar or fat jar if you want. Once that is done, I create some kind of temp directory where I extract the jar contents. And we are going to call that native image command line. And in this case, we are going to also specify a configuration file in order to deal with Java reflection code and things like that. So I'm not familiar with the syntax of this file. I just copied it from the existing project that I just showed you. And my executable will be called Spring Demo. There are a couple of flags to pass in order to avoid some issues with Netty. I want to build as many static libraries. I want to build with as many static library support as possible. So this is why I have that static flag. And here we are just creating a class path by basically splitting by concatenating the results of the listing of all the jar files in that extracted folder. Once we have the class path, I'm just pointing to the main class here. And that is all. So if go back to shell, and I will go to this project. And I look at the Docker build file here. So in order to build a Docker image, I'm not relying on any plugin. I could have used a Gradle plugin for that, but I think that the command line is kind of good enough for that simple experiment. If you take a look at the Docker file, it's nothing fancy. I'm using a multi-stage build. In order to do that, you would have to install locally a recent version of Docker. And I decided to go with Fedora just to make sure that I didn't spend too much time figuring out all the missing dependencies in order to run GraalVM. So once I have all some basic libraries installed, I download the release candidate 1.0.5 from the internet, from the GitHub, and create a bunch of environment variables. Once that is done, I just add this project without compiling it within the Docker image, so that we can build it inside the Docker image itself. So I switch to the application directory. I create the jar file using the Gradle wrapper and calling the assemble task. Once that is done, I create a temporary directory. That temporary directory will be used to invoke the native image command line. And this will be done by calling a build.sh script that I just showed you. once we have the Docker image, I just delete a bunch of folders that I don't need anymore. And I copy the resulting executable to user/bin/spring demo. And I delete some more temporary folders. So now that our binary is ready, I want to be able to create the smallest environment possible, just good enough to run the native image. In this case, I picked BusyBox with glibc support. I could not use the Scratch Docker image because of some dynamic library linking, especially for applications that require networking. So BusyBox is pretty small, and that was kind of good enough. So here I'm just copying the executable to user/bin, and I installed a small init system called Tiny, and that will just ensure that when I hit Control-C in order to stop the process from the Docker command line, it exits properly. The entire process to build this image on my machine is a couple of minutes. I did not really time it, but I think that it's between 5 to maybe 6-7 minutes. And I'm running a modest system. So this is a laptop running Fedora 27. I'm using a very lightweight window manager. Just consume maybe 4 megs of RAM or so. 3.5 gigahertz i7, 16 gig of RAM. But it still takes time to build the entire thing. But this is just for the initial build. So if I wanted to put all that production ready, to make it production ready, what I would probably do is create a base image until this part. So that would be kind of my build image. And I would add some code here as a layer. I would also probably have a base image for BusyBox, and or maybe not, because I wouldn't really care about having an init system even if it's small. I would probably just run the base BusyBox image and just put the binary inside it. So once the first build is done, all the subsequent builds should be really fast. And if I look at what I have in terms of images here, we see that that Spring demo application is only around, I would say, a little bit less than 50 megabytes. That is, it's pretty good. Because typically when I build some Java Docker images, we have to count at least 5 megs for the base operating system. If I use something a bit heavier, such as Fedora or even Debian Ubuntu, it's probably already around 200 megs of space, or just a little bit less. So when we look at 47 megs, I think that using Alpine Linux for a small Spring Boot application, I think that the smallest build that I've done professionally was probably around 70 or 80 megabyte in terms of image size. You see that here it's about half that, pretty much. So I'm really happy for that. So let's try to run it. And boom, it's already up and running. when I look at this, I'm very, very pleased with what I'm seeing. On the average day job, I would try to run it, and I have to wait a couple of seconds just to see all the Tomcat output and things like that, so it's pretty fast. If I switch the browser, I'll go at localhost 80. Okay, I think I have it open. Okay, it's here. And we see hello Graal, and if we go back and we look at the output, see that there is some kind of activity going on. And here we see what was written. So I think that GraalVM has a great future. I don't recommend using it in production unless you're doing a small command line application, or if you have a very simple microservice that you would like to run, because otherwise you're likely to run into some issues, and I don't know how much support you would get out there. So the main source that I'm looking at when I'm having some issues is the GitHub issue tracker. There are a couple of interesting things, and it looks like the GraalVM team is dynamic. I've seen a couple of people post their problems, and they're always trying to support people the best that they can. And yeah, it's definitely a project that I will pay attention to in the near future. And I think that they don't have yet, I think that they have a preview for Windows. But otherwise, you can get the community edition that works fine on the Mac and Linux. But right now, I only have a Linux system at home. My Mac died last year, so I don't have a Mac to play around with. There is an enterprise edition, so I don't really know what that means. I don't know if it's only in terms of getting support, or if it's significantly different in terms of overall features. And yeah, it's always good to have commercial support as an option. My particular case, I don't really care about it, and I'm hoping that once they make more advancements on GraalVM, we wouldn't have to worry that much about getting the Enterprise Edition. Yeah, I suggest that if you have a chance, yeah, give it a shot. I think that you might be surprised by how you can use it already. I think that as long as you're not doing tons of Java reflection and depending on tons of libraries that are doing some crazy stuff with the class loader, you should be fine. Thank you for your time, and have a good evening or a good morning, depending on where you are. Thanks.